Okay, so let's look at this book here. So we talked about, no, let's go through this. Okay, so we talked about these different kinds of graphs that you can make. We talked about a little bit about how to get help. So you can use this command, or you can put in a particular function name here using help, or a kind of shorthand for that is to use a question mark in front. And if you put in a double question mark, that gives a kind of more flexible search. So you might not have the exact name of the function, and then you can just try to guess the name of the function by putting a double question mark there. Sometimes it will find it. It'll find a couple candidates. And here, if you want to get an example of the function, you can do this. So why don't you try that with, I wonder what can put in here, try example and double percentage sign like we used in the quiz. See if that works. So put example, parentheses, quote, double percentage sign. Does that work or not? Does it give you examples? Yeah. Okay, so it kind of gives us examples. But actually, not so clear. Let's try another one. Let's try example, try this one. What's that give us? No, that's all right. Oh. Somehow it's not interpreting that the way I expected. Okay, that didn't work too well either. Let's try another one, simpler one. Let's try example sum. Okay, sum doesn't have any examples. Okay, any other ones we could try? Anything come to mind? How about matrix? Okay, finally we get one that makes some sense. Okay, so it gives you some examples of using a matrix function. Okay? All right, anyway, so that's something you can do. And you can search the R site also by using this command. So R, the R website, you can search for the function called foo. This one says, apropos foo mode function, list all available functions with foo in their name. I'm not sure about that, never used that, but we could try that one. Data, lists all of it, available data sets contained in the currently loaded packages. So let's try that. Okay, so these are all the different data sets that we can use right now. So like there's one called BOD, or let's see something a little more interesting. How about use stock markets? Okay, so let's try that. Now, how do you do that? I think you have to do Let's see how you do this. See if that works. Nope. Okay. Let's just try how about load? I forget how to do this, to be honest. Oh. How about if we just type, what? Okay. Oh, really? Okay, but how about if we just do this? Oh, okay. Looks easier than that. Okay, so you just type in the name, and you get the data set. And if you scroll all the way up to the top of it, hopefully it gives us some headers. Okay, so here you get the headers. So it's a time series, which is a particular type of object in R, just like we have numbers, and we have matrices, and we have vectors, and so on. Well, actually, we don't have numbers, but we have vectors, we have matrices, we have something called a time series. And anyway, this says that it starts 1991 and ends at 1998, and I'm not sure what this number and this number mean. And the frequency is 260. So anyway, here's the data set. We have to look up a little bit of carefully about what a time series object is to remember what these actually refer to. The start and the end are pretty clear. I guess this is probably the 130th day in the year, and this is the 169th day in this year. And frequency, not quite sure why that would be 260. Okay, so what do we get here? 1991, we get, not sure, why is that 0.496? Then we get these numbers, okay? It has something to do with the stock market. Okay, what are the other ones we could do? Let's try, anything else that looks useful? How about the Lake Huron? Lake Huron is the level of this lake. So let's try that. Okay, so this is just a single number, but it's also a time series because it's the level at which is appropriate. We would want it to be a time series because it's the level of the lake over time, right? I don't know, this is probably a year. So 1 year, the next year, the next year, the next year, the next year, right? I don't know, this might be feet, or I don't know what units this is being measured in. Okay, so we have data sets here that we can use to test what we're doing. We can just use these data sets. You don't have to get them from somewhere else. Okay, and when you use a new package in R, sometimes they'll have an extra data set for that package, like something that you can test the package on. And so you'll also have, when you add in a new package, you might have new data sets as well. Okay, what's next here? Vignette. Let's try that. Vignette. Vignette in R means like a file, like a PDF that has descriptions of how to use different packages. Let's see what we have. So these are vignettes for different packages, or it's like they're very complete help files, basically, is what we can call them. So is there anything here that looks slightly interesting? How about the introduction to the matrix package? Okay, so let's try how do we run that? I think we just use this, and we type vignette with that in the quotations inside. Don't forget, you can use the arrow key to get the last. Okay, let's see what happens. Okay, so it's going to bring up this, probably I think it's a PDF. Yeah. Okay, and it usually looks something like this. And it's a very complete help file on this particular package called Introduction, which is about matrices. Okay? So vignettes are very good if they're written. They're really useful. They're not always written. Okay. Next. The workspace. So this is a good thing to talk about. The workspace in your current R working environment. The workspace is your current working environment and includes any user-defined objects, vectors, matrices, functions, data frames, or lists. So when you create a matrix, that's in your work frame. That's in your workspace. Okay, at the end of an R session, you can save an image of the current workspace, and that's currently reloaded the next time R starts. Commands are entered interactively at the user prompt. You can use the up and down arrow keys to scroll through the command history. Doing so allows you to select a previous command, edit it if desired, and resubmit it. Okay, so let's try this. Let's try, so you've entered a few commands on your, just now. So let's exit. Find exit here. Okay, so this thing is in the way. Okay, so let's go to File and Exit. And let's see what happens. I hope it asks us to save the history, the workspace. Okay, so it says Save Workspace Image. So you click Yes. Okay. Now if you reload R, it'll probably reload that workspace. But if you're not sure what you can do, because what you can do is you can save different workspaces. So you're working on one project, you'll have one workspace, and then you'll have working on another project, you'll have a different workspace. So when you open it up, you'll get all the stuff that you saved. So this one though, we didn't change to a new workspace, so it's just the normal one, and I think that's inside. Is it in here? I don't think so, actually. Oh, there it is. I think it's this one here. So let's open it up and see if that's actually our workspace that we just did in Documents. So how I can tell that is, yeah, by hitting the up key, the up arrow key, and I see that I still have the history there. Okay? Understand? So what you can do is, like I just said, you can go to File and Save Workspace here, and you can save it into a particular folder, and that will have all, that will have all the data or all the objects that you've been working with. It'll save it there, and then if you want to reopen that workspace, you just locate where is it, and double click it, and then you'll have all of that. So you could call one of them like homework workspace, and then another one that you're working on some project with your professor, you could call it professor's workspace or something like that. So you'd have different workspaces, and you could manage them this way. Okay? Okay, let me do this again. There's a way actually to save the GUI. I think it's here. Let's try that even. Save the GUI settings that you make. So if I do this, and then if I go File, if I go here, and click Save, I wonder if this will work. So I save it. Okay, exit, save my workspace. Now I wonder if it will read the console file that I just saved. It did. Okay, so you can do that. You can save the settings. Now hopefully most of the time you'll be working with R Studio and not with just R like we're doing, because it's better. It's easier to work with, more convenient. But there's similar things you can do with R Studio in terms of saving workspaces and managing them. Okay, any questions? Okay, now, these are good commands. Get working directory and set working directory. So that's like if you're, you want to go to a particular directory, like one that has some files that you want to load, you can use these commands, get working directory, to find out the current working directory, and set working directory, and put in a path in here, and to change the working directory. So here, if you type in this one, get working directory, you can see that I'm in C users W cluster documents. Okay, that's the current folder that I'm in. And if I want to set it somewhere else, I can do set WD, and then open bracket, and then you have to put in a path, like this kind of path. So if I wanted to use this particular path, I could do that. Of course, that doesn't really make any sense, but you could do that. Okay, but that's the kind of string you have to put inside the set working directory. Or if this was set to a variable, if I set that to a variable like that first, right, then I could do this, right? What could I put in here now? Read the last line, and then what can I put in here? Yeah, my MYWD without quotes, not quotes. You put quotes in there, it won't understand. Okay, you can do that. I mean, it still doesn't complain. Okay? Okay. Try this one, LS. Let's see what happens. That stands for list. So what is this? This is a list of all the objects that I've created in my workspace. Okay, so you can see my WD is there. I guess I also have MDAT and something called X and something called X1 and something called X2 and something called Z. So if I want to see, like, for example, what is X2, I can see that it equals 0.2. Now I guess this, I don't know where this came from, but maybe I did it, maybe it's from last time or something. Okay? So that's what's in your, the objects that you've created. So like if you do FF equals 1 full colon 88. So what does FF equal to? That, right? Okay, now if I try the same command again, no, not that one, this one. So now FF is in my list, the set of objects that I've created. Okay? Everyone see that? Okay, so that's the ls function. And this one allows you to get rid of things. So if you have some big set of data there that's like 1 gigabyte of data, and you don't really want that to open every time you open, R, it's going to slow down everything. So you can use this and remove and the object list. Now it has to be object list, I'm not sure. Let's get some help on this RM function, because I'm not sure what you have to put inside there. So how do we get help on that? So just type in question mark RM. I don't think you need the brackets, but I'm not sure. Okay, so RM, remove objects from a specified environment, and it's supposed to be a list. So let's try and get an example of this. So here's temp is equal to this, so you just put that in there. Okay, so it's easy. Okay, you just put in the name of the object you want to remove, and that will remove it. Okay, is this clear? Now, you could do this though. Any guess what this is going to do? So it's RM, we're removing something. And what is it? What's this? That's everything in my space, right? That refers to everything in my workspace, right? LS, right? So what you're doing is you're taking ls, and then you're assigning it to this variable, and then you're saying remove that. Now it won't work, I don't quite get it, but it doesn't work if you just put ls inside rm. Let's try it. rm, but I don't know if you want to remove everything. But anyway, I think this doesn't work. Okay, it doesn't like that. So you have to assign ls to another variable, and then do it, and then it will do it. So like they said in the help, they assign it to, where is it? They assign it to list, and then you can, then it will remove it. Or maybe you have to assign it specifically to the word list. Maybe that's it. Okay, anyway, you can clean up your environment by doing this, using the RM. Okay, help, we talked a bit about that. Options, we'll talk about that later. History, you can display your last commands, so you can put in the number of commands you want to display last. Let's try that. Okay, so it gives you a list of the last 5 commands. I just did it with 5, so it gives me a list of the last 5 commands I ran. And then also the history itself command, so it's actually 6 commands. Okay? So you can do that. And what's next? Save history, so that's useful. If you want to save your current history of all the commands you typed to a certain file, you can just use this save history and give it a file name. Okay, and that'll give you the list of all the commands that you typed. So that might be, you might want to save that for future reference. Now, usually when you close R, it will actually create a history for you. Okay? But you might want a separate file like this. You might want to do this separately. And then you can use the load history, and you just put the name of that file in there, and that will bring up the history, so it will be loaded. So then you can scroll through those with the arrow key. Okay? And the save image saves your workspace. So that's instead of doing what we did, which was instead of going File, Save Workspace, you can type it if you prefer. You can type Save Image. Okay, and you can give it a name. Okay, and save object list file, so that just saves a list of the objects. I think it's just the names of the objects that you have currently working to a file. And then you can load that file, I guess. Load a workspace. Okay, and quit. Any questions so far? Okay, let's create a new working directory. So let's call it, well, let's get our working directory first. Okay, so my working directory is that, but let's make a new one. I wonder if we can create a file by doing this. Let's try this. Or okay, I'm not sure if this works, but right now I'm just creating a variable with this text in it. Okay, so everyone understand the first thing I'm doing here? Now I'm not sure if this will work. Not that will work, but I'm not sure if we can do this. Okay, let's see if that works. Ready? No. Oh. Okay, let's try, see if it works. If I first I create a folder called today. See if that works. So now I have a folder called, let's see if this works. Yeah, so it won't let you create a new folder this way, but if you already have the folder in there, then you can set the working directory in this way to another folder. Is that clear? Any questions about that? Okay, so here we have we're setting the working directory. Now you can type options, and I think it will list the current set of options, which we haven't explained. Okay, so all this stuff is under the current set of options. So it's like there are lots of options that you can set. Options for different functions, options for the way things are going to display on the screen, options for this and options for that. So there's many different options you can set, and you can look at the current set of options, how they're set now. Now I don't know what all these mean, but there's so many of them. So current number of digits here is 7. Okay, so I think that means the number, if you have a decimal number, it will display 7 digits currently. Okay, and there's so many different options here. Okay, so, well, that's the current setting though. Now, what we're going to do is change this this setting, which is the one I just mentioned, digits equal to 3. Okay, so let's do that. Okay, now if you type options, like this, again, one of those should be changed to 3 now, right? Let's see, where is that? 3 options, digits. Well, there it is, digits is now set to 3. Okay, so now we're only displaying 3 digits. Okay, now, this one is generating random numbers. We're going to be generating random numbers. This is a very useful function. It generates random numbers. And it's called RUNIF. UNIF stands for uniform, and R stands for random. So random, you understand. Uniform means, like, you can generate random numbers from different kinds of what we call, in probability, different kinds of distributions. For example, you could generate random numbers from this distribution. That's a bell curve. Okay? So what does that mean? So that means that it's very likely that you're going to get numbers close to 0, and not likely that you're going to get numbers out here. But you might sometimes get numbers out here. Okay? So that wouldn't be called that's not the uniform distribution. The uniform distribution is flat. So all numbers are equally likely. But I think it's the numbers between, I forget. Anyway, let's try this. X, and this is going to generate 20 of these numbers, random numbers. So put that in, and then if you want to see what numbers were generated, type X. Okay, so these are numbers between 0 and 1. Random numbers between 0 and 1. Okay? Everyone get it so far? Okay, so we did that. Now what summary is a very good function. That's not sum. Right? That's different. Sum, if you want to do sum, let's try sum just for fun. Okay, so that's the sum of these random numbers. Okay, but that's not what we use summary. Summary is much better. Very good for the data analyst. Okay, let's try it. Okay, it's not that detailed, but not that much stuff. But I guess there's not that much stuff you could do with these numbers. Just a set of 20 numbers. So what does it tell me? Well, here we have something that says MIN, that means the minimum. Here up here at the right-hand side we have something called MAX, that's what? The maximum. And the mean is what we normally think of as the average. And the median is something similar, but not the same as the average. And the first quartile and the third quartile. So let me ask you, if you took a test along with 10,000 other people, and your score was the third quartile score, what would that mean? You took a test with 10,000 other people, and your score was the third quartile score. What does quartile mean? What does quarter mean? 1/4, right? 1/4. So third quartile means 3/4. So what do you think it means that you would your score was the third quartile score? And let me ask you, would you prefer to be the third quartile score or the first quartile score? Third. And what does that mean to be the third quartile score? It means 3/4 of the people did worse than you, and 1/4 did better than you. Or in other words, 75% did worse, and 25% did better. If you were in the first quartile, what would that mean? 25% of the scores are lower, and 75% are higher, right? So what's the first quartile score in this data? It's what? 0.259. What does that mean? In this data set, 25% of the data is less than this number. And what's this third quartile mean? In this data set for X, what? 75% of the numbers are less than this number. Okay? So that tells you kind of how spread out this data is, right? If this number was 4.9 and this was if this number was 0.49 and this number was 0.51, what would that mean? Like most of the data is right between those two numbers, right? Okay, so it tells you how spread out it is. Okay. And HIST, let's try that. That's going to make a picture of this data. Let's try it. Okay, that's a histogram of the data. Okay, so what was the first quartile score? What was the first quartile score? What was the first quartile score? 0.259, right? Where is that? 0.259, that's right around here, right? So this is where about 25% of all the data is less than here. And where's the third quartile score? 0.647, 0. Somewhere around here. That means what? 75% of the data is less than here. Okay? Is that clear? Okay, save history. We talked about that. Save image and quit. Any questions about that? Here they talk a little bit about something about Windows and Mac, but I'll leave that for Mac readers to look at. Okay, next thing is input and output. By default, launching R starts an interactive session with input from the keyboard and output to the screen. But you can also process commands that are in a script file or in a file and direct the output to a variety of destinations. So you can read some file that has all your R commands there, and you can have the output written to someplace else. Okay, instead of onto the screen, like you might want to have a file with the output, right? And just have it all saved to a file. So how do you do that? If you have a script, or a script just means a bunch of R commands saved in something called file name, as long as that's in your working directory, you can just do source and that file name. Okay, and then all those, whatever R commands that you have in there will be run. And then you can also have the output to another file. So let's try this with our current commands. So let's get our history. How do we get our history? Actually, how do we get our history? I forget. Well, anyway, I forget how to show it up on the screen, but we can just go and get it from our here. By the way, I didn't say that before. This is your history file. And you can just right-click on that and open it with some kind of editor. And on these computers, we have a very good one that I recommend everybody get, called Notepad++. So if you right-click on this, Notepad++ is available. You can open it with Notepad++. It's just an editor. Just like Microsoft Word is an editor, but this is a very good one for programming. This has all of my history, except that it doesn't. It doesn't because I didn't save it. So let me close that. And let me save my history first. So let me close this. Go to here, File, and Save History. And now, save it. Now, oh, but I'm in a new working directory. Okay, maybe that's why it didn't have it. So I have to go to my working directory, which was today. And now I have the art history there. And open that with here. Okay, so this is all the commands that I've been using. And now let's just take these here and put them in a file and run them. Okay, so just take, you can choose what commands you want, but I think these are the convenient ones. Okay, and I'm going to copy them. So it's just X gets set to that, display X, summary X. That's all. Okay, I'm going to put them in a new file. So I'll just go to File and New here, and put them in here, and save them in the same directory that I'm currently in. Save as, and I'll call it. I'll just leave it just like that. I'll call it New 2. Like that. Okay? And that's in the same directory. All right? Now let's try. I don't know if we have to create a new file. So let's try source and that, which was called New 2, and sync. Let's see now. Let me make sure I'm doing this right. First, you have to write sync. So write sync and call it my output, and that's all. Just sync my output. Okay, now hopefully this works even though we don't have a file called my output. I think it will write to it. Okay? So now what's going to happen is anything that we do is going to be not shown on the screen, but rather written to this my output file. So now let's try to do this command, which is